Yep, and recording is on. Hello and welcome to our next part in the series of writing a code editor in Zig. Last time we stopped at basically printing something to the screen, and now I spent some time writing it. We have some more abstractions like key and UI, which is supposed to be a generic user interface abstraction, and an event dispatcher. I thought maybe we should have some kind of an event listener that's going to respond to all the events. The idea behind that is that we can have both synchronous and asynchronous events. For example, the easiest way to do it is to set a while true loop and just wait for key presses. But the thing is that we can have asynchronous events like the file we are editing was updated by another program, and we want to reload it to show the new content. This is an example of an asynchronous event. So in the end, we will have to somehow include them, right? So for now, I thought about our interface. We should maybe start with something that is fun, and for now the very first thing to do is to build an interface. Just display something on the screen, right? I thought that new cursors implementation is it's very frustrating to build bindings to. Here I have some new cursors. This file, it is already 1,500 lines of code with a binding, and it is maybe a third of everything that is in new cursors, right? And I don't think I will ever finish it. It also has very confusing things like with wide character support for UTF-8 and without, and you have to supply compile flags, and I'm just not sure I'm ready to deal with all this complexity. At first I thought that maybe this new cursors library is a fast start library, so we can hack something fast and go from there, but now I think maybe we can actually exercise our power to write everything from scratch, right? There is a saying, I think it's called like this one. Yeah, not invented here is a tendency to avoid using or bind products, research, standards, or knowledge from external origins. Yeah, it is usually adopted by social, corporate, or institutional cultures. I guess we are social, we're not corporate or institutional. I don't think I understand what institutional culture is. Research illustrates a strong bias against ideas from the outside. Well, we are for ideas from the outside. We are happy to use ideas from the outside, but we also want to rethink it, you know, like when a designer gets some pattern, or how to say, some draft, right? And to the designer, manager says something like, here is a draft, do this one but rethink it. Yeah, something like that. This is what we basically want to do, I think, and we will also do it in Zig, which will increase the power to like the ability to hack on it and improve it and use it for all the specific use cases. I agree that this is a bit maybe far too much work, than adopting existing solutions, and it has some downsides, but we will roll with that. Okay, term pejorative sense, or pejorative, I don't know the exact meaning. Yeah, something negative, something disrespectful. Okay, so let's begin with some abstractions again. We have this printing. This is basically all the new courses stuff that we have. And we can now kind of dissect it in different parts. We can call it, also put it in some struct, which later will be a separate file. And we can call it something like initialize, draw, and wait for a key event, something like that. All right, let's put it here. No big deal where to put it. Pub const, and we will call it. We have UI, and UI is supposed to be a general interface, and we will build an implementation of interface. Right, so we can put it either in UI struct or to create a new file. Yeah, I think new file is better. We can just do something like that. UI VT100. This VT100 is like an ancient terminal, like a real hardware terminal, like when you just boot up your Linux machine or macOS machine if they have it. Yeah, I think macOS doesn't have it. And on Linux you can press Control-Alt F1 or F2, F3, and it will get you to the real hardware terminal, as I understand. And VT is like an ancient dinosaur of hardware terminals. It's from what I've read, this VT established some like ANSI escape codes, which were widely used after that, and now it is de facto standard of how to display things on the terminal. And every modern terminal, for example, this is Kitty. I use Kitty terminal, like so, like Kitty. There is Alacrity, another terminal, and like iTerm for macOS, Xterm somewhere else, a lot of them, and they all speak these ANSI escape codes, and we will, for convenience, call it UIVT100. All right, so we want to implement some functions. We want to initialize, we want to draw, like a full draw, first draw when we just load a file, and we want to read a character from the standard input. I believe this is how we're going to do it. All right, let's start by writing init function. So far we don't know what it is going to take, but let's just start there. So on the terminals there are some ancient things, and for that we will use the proof of concept editor. It is called Kilo. Let me find, do I have it? Yeah, I think I have it here. Kilo. Yeah, this is a very cool thing. It's like 1K C code, and it is not like usable, but it is a very solid proof of concept. And I also have the sources downloaded here somewhere. Kilo, right. Okay, so now we will need to initialize do some initialization. Enable raw mode. So does it have initial? Yeah, let's get to the main function. Init editor. So we basically want this thing. Update window size signal. Okay, so update window size. Yeah, we should also care about window size as well. So I guess we should just copy everything that's here at the beginning at least. Let's see what this update window size function actually does. Okay, get window size, screen rows, unable to query the screen. So we first get our size, and then we okay, and this is we get the number of lines we have, and we reserve 2 lines at the bottom for the status bar. And do we need to do something here in this function? So not yet. It just does some syscalls and retrieves the necessary dimensions of the opened of the space real estate we have in the terminal. I think we don't need this one. Highlights. Yeah, we don't need highlight yet. Editor open, we already have that. It opens a file, and we should have it already, if I remember correctly. Yeah, we have even a special function. It doesn't read from standard input yet, so we can do something like this. Right, so far this doesn't work. Yeah, we even have a nice error message if we don't supply a file, but we will do it later. And enable raw mode, I believe this is our bread and butter. So let's just call it like so, I guess. Enable raw mode. Well, no, it's just we'll have an init. We'll use a slightly different naming. Okay, so first thing we should do is name get our stdin file number. Let's do it UIVT. Yeah, we'll have the standard library of nim already should have something like that. stdin. No, okay, maybe linux.zig. Maybe get std out, something like that. Get std. Maybe we can grab it. Get std in. Oh, it's in IO. Alright, get std in handle. So we will have our std in, which will have yeah, so far we'll use maybe OS will use it quite often. OS dot fdt. So we will need it in a couple of places, but maybe we still have to need this one. So maybe it is going to be a file instead. Yeah. Oops. File. Yeah. Maybe IO file. IO.file. And we'll have IO Is this good? What is it? Expected while suspend syntax error, I guess. It is a type, right? Let's see where the file comes from. File import fs file. Okay, we can do that. stdfs file. stdfs file. Okay, still not. Expected while blah blah. Did we mess something here? No, not yet. Let's run it. I don't understand why it doesn't want to work. Invalid token identifier. Maybe I don't know how to write Zig. Oh, struct. Yeah, sometimes it happens. So on init, we will definitely output our UI VT100, and we will create it at the very end. We'll return it. UI VT. It's a bit uncomfortable to type it and all the capital letters. Yeah, let's. We will have to use this std in before, so let's just define it. IO get std in. IO get std in. Okay, seems right, and we will supply this here too. The reason we supply it and not just call this function all the time is because we might have scenarios where our standard input is going to be something else. Maybe like in testing scenarios where we want to test something and we want to read our input from the file, not from the actual terminal std in. Okay. Now we can do some magic. Struct term ios raw. Okay. If is tty standard input file no go fatal. Okay, so we check that we want our input to be a terminal. I wonder what happens if it is a pipe. Is it still a terminal or not? Probably not. Okay, and we have a disable raw mode. Yeah. So what we do here is that we have some initial config, right? Here, orig term ios. We have initial config, and we want to save it, then modify it, use it, and when we exit our editor, we want to also remove all the settings we added so we don't leave the terminal in the broken state after that. Okay, let's do some things like here. Zig has term ios, if I remember correctly. This term ios.zig. Okay, maybe it has something here, right in this file, term ios. Okay, maybe it is in OS module. Yep. We have here our functions that we will use to save and modify the state. Okay, now we just copy what we have here and raw mode 1960 magic shit. Yeah, I can relate to that. Right. Let's start with we need a structure term ios. Okay, var raw, it is of type os.term.ios. Is this correct? We should get it somewhere because it is a type, and we need to get info where this type is defined. Maybe there is a using namespace somewhere. OS bits. Okay, so it means that we are in OS bits. Can we find it in OS bits? So I suppose no. If we use using namespace and pub, that means that we will have every symbol in OS bits also imported in this module, and this module will re-export every symbol in here. So we can use os.term.io. Term ios. Yes. I'm not sure how to correctly pronounce it. It will have type OS term iOS. And it is undefined because we should initialize it at least to something, and we don't want to initialize it yet. Okay, so we have it here like so. If not is a tty, go to fatal. Okay, so this will translate roughly to something like errors. We should have an error set for that. Error. And for now is tty. Maybe it is in IO. I remember there is such a function. Tty. Oh, it's here. All right. Is a tty in OS. All right. So we don't have a native error for that. Let's just create one. Not a tty. Or just not tty. Yeah, sounds all right. So we can have this error returned, and we will do a check like in here. If we fail, we just return an error from the error union. Our Zeek will help us with handling that. If not os dot is a tty, and we pass it a handle dot handle. We say it's bad and we want to quit. Yeah. We say return UI VT error not tty. Alright, next line we want to do something at exit, editor at exit, and we want to disable raw mode. And at exit is, I guess it is something C specific or something imported in these headers, because I do not remember encountering this at exit somewhere. Let's just move to the next line then. This one we get our original term iOS. And why do we get it? Why do we get this orig term iOS? Oh, it is static. It means it is local to the whole file, like a global variable. We probably don't want any global variables, so we'll just create here UI VT. This is still an interface. So yeah, maybe we should also move raw here. It makes sense, I think. Okay, raw is OS term iOS and original term iOS, OS term iOS. Okay, so maybe we should change our structure a bit. We will call it result. We'll initialize this result, and we will put everything we need so far in it. We will say that raw is undefined, and original is also undefined. So we can directly reference any results from this structure. Okay, then let's actually copy this line, and this will be tc get attribute, tc get ttr. Right, it can also fail. Let's add this error union. It will be like so. Yeah, I think like so. We can add our error unions together so that they can be like, oh, I got my stream down. Is it because I don't have internet? Oh yeah, I don't have an internet. I think I will have to fix this. Oh, I have internet. Sometimes it happens, just random Wi-Fi down. Okay, so let's continue and hope that we don't have our stream crashed. I still record things locally, so I should be able to get a clean recording of it. Okay, let's say so we are trying to copy this line for about maybe 5-10 minutes now. Very new for me, so I'm not very fast with it. Okay, we get OS tc get attribute, OS tc get attribute, and we pass handle. We get it from standard input handle. Okay, and we just return our original result dot original term iOS. We got it. Okay, looks good, looks good. Now we say that we want to copy it. Let's copy this to raw, and maybe if we call it like original and raw, it's not their meaning is opposite, but we don't say it in the name. So I think a good strategy is to also make names right. And at the very start of the project, I think it is still important to name things right, maybe even more important than later when we have already an established architecture and we know what we want to do. Original term iOS and raw term iOS. Maybe just term iOS. How do we even use this raw? We just have a raw mode, and we don't even use this raw anymore. We just temporarily. Is this correct? We don't use it anymore. Raw mode. Yeah, we just use it temporarily to modify. Yeah, internet is down. Whatever. I still recorded. Okay, so we don't really need this raw. We can delete it. And we can move this somewhere here. Yeah, like here. Var raw equals result original term.ios. Yep, seems okay. Now we want to modify it. Yeah, we have it copied here. Raw.ci flag. Yeah, can we do that here? We got our term.ios, and I assume it should have same flags. We need to look at OS bits, and yeah, we should look at something specific bits Linux and term iOS. Okay, so we have it like so. Yeah, it seems like it completely copies everything it has. Let's do what this thing here does. Raw C flag, we do an AND with negated OR of these flags, so it means we don't want all of them. Okay, let's do that. C I flag, and we want to end it with, so can we just, yeah, we can. OS ICR NL os.in pck is strip, oh, with just a single s, is strip ixon. Okay, so my internet is down, and so far I don't need it, right? Let's see O flag. Now we have another O flag. What O flag? Just O post. Yeah, but we still don't know how it's going to behave. Maybe we should try. Is this going to compile even? Let's try just to call it init and see if it's going to compile. Maybe we should do something about it. We don't care about anything else right now. Just try, and we're going to compile. Redefinition of raw and expression of value is ignored. Use of a declare identify result. Okay, let's fix all of these errors. Then 199 var raw, where is this defined? I think I know. Yeah, it is from new courses. Okay, let's comment all the code here. And let's not do using namespace. And then result, we don't have it declared. Constant result. Cannot assign to constant. Okay, variable. And yeah, I got an idea. We'll call it raw term.ios. No member named CI flag. CI flag, just I flag. Okay, it is here. Unable to perform binary not operation on type comp time int. Okay, so it means that this thing here in brackets doesn't have a type defined, and since all these things are compile time integers, it tries to guess and it cannot guess. So we should probably give it a hint how to interpret these things. And what should it actually be? We have a Zig example somewhere in Zig courses. So in main, I think. Yeah, and it says that it is U unsigned 16, unsigned 8, unsigned 16. Why does it arbitrarily say it is 16 and this is 8? Yeah, I have no idea. Okay, let me do a quick run. I need to quickly. I need to take a minute, but I will be back soon. All right, hello. So I think we have some connection. Beautiful. Let's continue. So iFlag, it doesn't really say what kind of flag it is. So maybe we can Google it to understand which type it is, or we can just try and guess like which type it is. Okay, let's try guessing. What if it's going to be? Oh, maybe we have term iOS, right? We have this type, so we should just transform to this type. Yeah, it is tc flag t. Okay, so we apparently can do or, right? But we need to have. Okay, let me try this. If we say that the first member is this type, is compiler going to understand that all of them should be this type too? Yeah, I like it. So did it do something? I don't know. Let's just reset it. And let me turn on the stream. I have one stream that's finished, and save login. I don't want to save my login. I got internet disconnection and now I cannot restart my stream. It's like a new stream. Okay, well, we shouldn't care a lot. There were no viewers anyway. I think we should just continue with that. C of flag, it's going to be, maybe we can make it a bit prettier here, like so. No. How to make it a bit prettier, like so? No. Can we just to the next line, like so? Okay, it looks fine. Sorry. For a moment I thought that Zig FMT, the formatter, is going to interfere. O flag. And what do? We also end it with an negation of OSTC flag T and O post. Yeah, we have that. And C flag, as I see here. Yeah, I saw it says like what is the number of bits that it is going to read. We will use 1 byte, right? Because we are living in the 21st century. Not a lot of machines have different sizes than 8 bits. Raw term iOS C flag, and we OR it with os.cs8. Oh, apparently we don't have it. Well, do we have something else? Maybe we can find it together with icrnl. Alright, familiar flags. What about? No, we have it, just our auto-completion didn't highlight it for us, so we should be good. And now local mode. I don't know, well, here I kind of understand what these do, and local mode I'm just fully unaware what it does, and I hope I won't have to understand it completely. It could be just ancient machines with serial ports and stuff. L flag and okay, something is strange going on with the stream. I do not understand. Connect streaming software to go live. Stop in stream. Okay. Internet connection is not the best, so I guess I shouldn't expect that everything's going to work as I want. TC flag. TC flag. Yeah. Typo here. TC flag OS dot echo, and we OR it with ICANON EXTN and ESIG. Okay, so far so good. Now we also say this and this, right? Term iOS, CC, this term iOS. TCSA, we also have it, alright, it's good. And CC and CC and like 32 bits, right? And we have vmin, I suppose. Vmin. Okay, vmin equals to 1, or sorry, 0, and vtime equals to 100 milliseconds. Okay, that looks good. Put terminal in raw mode after flushing. So we have constructed our structure. Let's now apply it to the terminal. Raw mode, so do we want to have a raw mode? Yeah, probably not. I don't see a clear reason to have it. Let's just apply it and hope for the best. Try tcset. Oh no, try tcset attribute. So let's just tcset attribute. Just grab for it because there are so many places where it can be. It is in OS, right? Term iOS get error, set error. We also have to change the error union here. Get to set. OS tc set attribute. Handle, it is standard input dot handle. And optional action tcsa. So we saw it, tcsa dot, and it is something which we'll fill in a second, and like so, right? Right. Okay. And we need this tcsa, which was the bits, I think. Linux tcsa. Maybe in OS tcsa, maybe in IO. Okay, so hard to navigate it. Bits Linux. Yeah, in os.tcsa.flush. Is this correct? Yes. Flush. Okay, is this going to compile? And we also want to have a dinit, but for now let's try that. Okay, use of undeclared identifier. Yeah, they should be qualified with OS module. And do we have a broken terminal? No, we don't. So does it mean it worked? I have no idea, but let's maybe it tries to optimize it. Const UI like so. Oops. Usually when I have a broken terminal, something strange happens with new curses applications like these ones. So far nothing strange. How do I even tell if like something is happening? Do we just believe that everything is fine? Well, we didn't get any errors at least. Okay. No idea how to check it. Let's just roll with that. We have our raw mode, and let's just denit our raw mode. Right, we will have pubfn denit, and we will pass self as a pointer UIVT. And we will it will be void, and it can also fail UIVT error. So what does it say about deinitialization? Disable raw. So we just remove the old setting. No, I mean we just apply the original setting. Yeah, it looks fine. So when we deinit, we also want to put standard input and original term iOS to some states, I guess. And here we have this raw mode to do something in case we already have set it. Yeah, here we can do what? We can just make this a nullable field and say that if we have something in original term iOS, it means that we initialized and we should restore it to something. And after we restore, we can set it to null. Yeah, I think it makes sense to do so. Yeah, and we write it like so: if self original term iOS orig, or just term iOS, we do try tcset attribute cell as the in handle. Do we do it in tca flush or something like that? Yeah, tca flush, same stuff as here. Let's just copy it. And we use this original term iOS. Yeah, like so. This looks fine, and we can just put it in the defer statement. We can do what? We can also have an error defer if we fail to initialize, we want to clean up. This is the first time I will use the error defer construct of the Zik language. Okay, let's put it where? Maybe after we initialize it. Something like here. Yeah, because we initialize it and we want to de-initialize it after that. That's also original. A good practice to put null in every value that we de-initialize. Defer de-init result.de-init. Okay, that looks right. Let's put some code in here. Const UI, and after we create it, we also want to deinitialize it. We kind of repeat the code here and here, but at the same time it makes sense because we want to be clean when we initialize and we get an error. We want to clean up the state, right? If we get some troubles, we want to put it to null, I guess. It's kind of say that this is free space. You can get your memory back. I guess it makes sense to do so. And yeah, let's try and put something on the screen. We spent some time trying to initialize it properly. Now it is the time for the fun part, I guess. We want to put something on the screen. We will use the simplest method possible. We will just directly put characters on the screen. A more smart solution would be to use buffer, put it into buffer, and then put it on the screen with a single command. But we are not smart just yet. So far we can allow ourselves to be a little bit more simple and dumb. Okay, so we'll have print, I guess. It is in the struct UI VT100. And we will print characters. Do we want to have the same thing that Zik has like a reader interface. Yeah, maybe a bit later. For now, let's not even print, but just add string. And we will add everything we want to add to the screen. We want to take a pointer to self by VT100, and we want to get our string. Yeah, const u8, and we can fail doing so. So I guess we also want our std out in the initialize, because we should know where we are supposed to output things. Alright, it looks similar to this one. We just change in to out. Okay. Add string, and we say just self std out writer dot print write all string. Yeah, it looks like so. Let's test it. It looks very simple. I thought that we will have to spend like this many lines of code. Maybe it is a lot simpler than I thought it is, because it seems really hard after porting the whole new curses library. It looks like very hard. So now we use our UI. We don't need a dumb assignment to nothing. We say UI, we say try UI, add string, and we pass our hello world. Are we going to succeed? And let me see, we should use try here, as I understand. Okay. Yeah. And we should wait some time for the screen to not go away. The moment of truth. Okay, let's solve some errors we have. And one here. I flag type Linux does not support field access. So this is nullable. Result original term. Oh, I see. We made this thing nullable, so when we reference it here, we should also say that, yeah, we really do want our original term iOS. It is not null. Error is ignored. Consider using try, catch, or if. Yeah. So I'm not sure how to properly handle errors in the defer statement. Maybe for now I will do it like this. That's catch and something like this. std debug.print UI VT100. Yeah, maybe we should do it in this function as well, or no. It will be a bit wrong with abstractions. Dneat error. Yeah, 3 R's is the right amount of R's. Yeah, like so. Now they all seem to use same error, and 1.8 this one, self dot stdin handle. Okay, so about these handles, maybe it is not very wise to do so. What do these functions actually do? Get std out, std in, out. So they just construct some conditions. So for example, for Linux, IO, get std and handle, they're kind of cheap, right? Maybe we shouldn't keep them and just treat them as if we always can recreate them. And it also doesn't make sense like doing a stream, because we can also always do this thing. But it also somewhat makes sense because we can redirect them. Std in, std out. Can we use words in and out? In stream, out stream. Maybe these are correct names. In stream, out stream. Because std in and std out, they bleed to many implementation details. Okay, let's just use our brilliant ZLS for renaming. In stream and out stream. Our stream. Our stream. Now this is our stream. Alright, and like so. And maybe even result the init, like so. Return and just put it in line, like so. Yeah, this looks cleaner to me. Let's try to compile it one more time. No member named std out. Okay, it didn't our stream, we should say. ZLS didn't rename it exactly completely in all places, or exactly in all places, like here too. It is also possible that when we have something on the screen and we would like to inspect a character, we will read from our out stream. Usually we write to out stream, so it displays on the screen, but I don't know what it's going to be when we read it. And I also don't know, we almost always read from in stream, std in, but what if we write to std in stream? It is going to be like a loop and we will read same stuff which we write. Using try 177. Yeah, here we want to just do nothing, I guess. Or maybe just same stuff, same as here. We here try to be clever and use zigzen, and it says resource allocation may fail, resource deallocation must succeed. So I guess this kind of stuff is the implementation. I'm still not sure about it, but it looks like it should be. 193. And it says no member named std in instruct UIVT. Okay, it is the wrong line for sure. 195. Yeah, here in stream. And whoa, did you see that? We did it. And what if we go with that? Oh, so good. Yeah, we did it. This is like a typewriter. We put just new line and it goes one line below, and we put a carriage return and it goes to the very beginning of the stream. So it's like a real typewriter, you know. The typewriter is like a mechanical machine where you press buttons, they click clack very loudly, and you have something on your paper typing. And there was a carriage return that you press it and it puts this typing head at the very beginning of the typewriter, so we can type from the new line, right? And on Windows, this is still like a canonical line ending, and Linux says, okay, we can use just /n. But now we are in a land where everything is manual. Sometimes it's good, sometimes it's not so good. We will see. So far it looks nice. We did this stuff. We can safely delete it. Then we can delete this stuff. Okay, so we have hello world. Maybe it's time to celebrate and commit our changes. Hello world with handwritten VT100 backend, yeah? UI backend. All right. Let me drink some like victory tea. All right, let's try to display the actual content of a file that we have. I think it's a good idea. So we will basically use this code, but we will write it with our own implementation. So here we try to count lines, right? Okay, we have some things, and we are basically interested only in this stuff. So I know there is a difference between printing a string and printing just a single character. Even in terms of terminals, they have some kind of optimization for single character things. So yeah, maybe it's also not so true, because we're not going to print single characters on the screen when we draw it in the very beginning. We still want to put it in the buffer, so any abstractions at this point would be irrelevant later. Yeah, let's add string, and we pass a single space as a string. I think we can also like expose a writer, right? Zig has a beautiful interface with reader, writer, and I think we should just expose the writer interface. Yeah, what do you think? I think it's a good idea. We just say here's a writer, you can do whatever you want with it. Yeah, I like it. I'm a fan writer. It's a classic function. Classic function name, I should say. And we just io.writer, I guess, like so. Turn self outstream writer. Yeah. And we can do it here, writer. And we can use everything from the writer interface, and it's quite a lot. Here's like some native stuff. I still do not fully understand how it works, but there are some nice functions, like write byte n times. This is what we are actually going to use. Let's just copy it here. Write byte n times. What we do here is we manually write byte n times, and in Zig we have even a special function for that. Wow, extra optimizations. Okay, so self byte n size. This is our byte, and we write it exactly I times. Yep. And we also want to do some printing, and UI writer print. And try refresh. We don't have refresh. So how do you like it? Let's see. I think it's going to be broken because, for example, here we have to use this carriage return, and we should insert it somewhere. But let's try. It is going to compile. So far, no. 188 here. Okay, one more time. 188. 188 here. So it needs some kind of a type, right? And for outstream we need a type. It is from file, right? We have outstream is of type file. Maybe file has some type for us. Writer. Yeah, we just should use the file one, not a generic IO writer. Yep, here, and it is stdfs file.writer. Yeah, that is what I would expect. So this is all good, right? We just need to do a carriage return when we insert a new line. So far, so good. So far, so good. Okay, so there is also a problem with this exposing directly a writer, like so, as a to this outstream, because we probably want to do some additional writes, right? Like here on every new line, we also want to add a carriage return after that. And it's why is it slow? We probably wait in not a good time. We have a wait here, like time sleep, and we sleep before actually printing something. Let's do it here. And since we don't clear anything, we can actually not wait. Yeah, now it's fast. All right. Now let's try and do it in a smarter way. So maybe we can write, maybe we can expose our custom interface. Maybe we can call it raw writer, right? Because we expose it directly like for our std outstream, for all the escape sequences and so on. But we can also write our custom writer. Yeah. And we can just copy implementation from the file. we will need a function that does writing, and we will need basically need something like that. And maybe we also want to get a look at this write interface implemented not in the file but in array list. There is a writer interface too. Yeah, and they have append write specifically for this writer interface. So we want to implement something like that. Let's put it here. Yep. Yep. So stdio writer self, a pointer to self. In our case, it will be this name, yes. Or we can start using self. I'm still not sure what's better. There is a convention that you can use just like so, and instead of this term, you will use this self everywhere, but I'm not sure how well is it. Standard library also doesn't use this self consistently, so I'm a bit I have some doubts whether it is a good or bad approach. So when in doubt, let's do things conservatively, if there is such a word as conservatively. Out of memory, I am actually not sure which we should have this function which is going to tell us what errors. This function should return these kinds of errors. So far we don't know what are we going to return exactly. Maybe we can call it writer fn. We also have this struct here, m. Why is it m? At least stir for string. Now we can return the size of the string to conform to the interface. And now we probably should just use same errors what fs file writer errors. Yeah. Writer fn. Let's go to fs file. Which errors does it have? Write error. So fs file write error. std fs file write error. Write file error, write error. Yeah, let's just use write error. And now we do try get no, we should do it a bit smarter. We will have our raw writer, that will be self.raw writer. Okay, and it can be a const, I guess. Is writer a const? I don't know. Let's use a const. If it's going to be an error, we will change it to var. Now we want to be smart when we want to write something to the raw writer. Let's do an iteration. And let's use full names. It's like we're not in C world. So we iterate over every character, and we do what? We want to write it using a raw writer, but if we encounter a new line, we also want to add carriage return symbol to it. Okay, this sounds correct. we will our raw writer, and let's have a look at the writer interface one more time. Print write byte. Yeah, we will use write byte, I guess. Write byte. And this byte. And if our byte is new line, we also do write byte, and we write carriage return. So we we don't need to change anything up because we use same writer function, and the old function we used was renamed to raw writer. Let's try now. Okay, we should use try. One more time. Redefinition of raw writer. Yeah, we cannot use same functions, and variable names are not allowed, I guess. Also there is string. Well, sometimes it's good that we don't have a single we don't have like a space for variables, for variable names, and some space for function names that live in two separate worlds. Everything is in one, but it's also sometimes a bit annoying when like, how do I call it, like get raw writer, like OOP world, object oriented. Maybe not the right idea. Maybe we can just call it writer, but it will conflict with this. Okay, this is why we'll have to use something like raw RTR. Writer. No, I don't like this name. Okay, raw writer option. Well, I think maybe you can just use it like so, because this function doesn't really do much. Is it inlined where it's used? Right, no, it's not inlined, so let's not inline it either. And wow, we printed everything. Wow, what if we want to print more than the screen size? In the new cursors implementation, we got a crash when we tried to print more than, this is about, like here we see like 54, right? So it's like about 54. We have maxed height 24. Let's put it to 100. Yeah, I like it. We made a cat program, but better, I guess. Oh no, maybe not better. I'm still not sure if we get the right terminal, like terminal state, because it prints it here, and new cursors does not print it like here. It just creates a new terminal, completely something new. Let's try maybe to sleep for some time and only print good old 24. Okay, so what I want to do is I want to clear the screen completely, like this one shouldn't be here. So maybe we can also put it inside initialize function, because when we initialize we also want to clear the screen. Is this right? Probably yes. So do we have something like clear in the kilo, our proof of concept implementation? Clear. No, we don't. Okay, so we use in raw mode, but now we need some way to acknowledge that yes, we did use raw mode and we got some benefits, because so far I don't see anything particular about this code. Like, what does it even do? Why did I write it for 20 minutes? Well, so far it looks like I'm doing everything correctly. OS, yes, term iOS, and set, get, no pointers, everything should work correctly. We should get all the errors. Okay, tcsa flush. What's flush? Maybe we should read the main page on this thing and get the flush. tcsa flush. The change occurs after all output written to the object referred by fd has been transmitted, and all input that has been received but not read will be discarded before the change is made. Okay, so it shouldn't affect anything, because it just says that we will apply these settings after my shell. I use fish shell after my shell finished with all the input-output procedures. So maybe there is a code, like escape code for clearing the screen, and we can just write it somehow, like fn clear self UI VT100 void. We'll do something like raw writer, and we will add several bytes. We say write all, and we supply a string we want to write. So I have some codes. Maybe we can find something to clear the screen. Okay, next, maybe here, clear. Load the next page in many and may be used to separate logical division code. Some terminal it clears the screen. Still some command plain text as a page break. Yeah, this is a page break. Maybe we have something better. I remember I have some codes. Yeah, this is escape sequences. Probably what we want to do. This is our escape sequence. 2J. Let's find it here too. 2J. Here's just J. And 2J. Clear entire screen. Yeah, this is what we want exactly. And since we want also to print an escape sequence, we'll use print. We will use this C, I guess, for a single byte, right? Let's check the FMT, I think, for a byte. Okay, not here. Here's the specification of all the letters that we can write. UTF-8 integers, ASCII character as an UTF-8 sequence. Yeah, I think we should use this C here. This like big enough, yeah. What's standard? Yeah, 1+. I use one size larger than my standard font for recordings, so you can see it better. And we have somewhere like ASCII, right? ASCII std ASCII control code, and we have in control code escape 0x1b, classic like starter of the sequences. std.ascii.control code.escape. Okay, now clear the screen. So this is escape, as I understand, and we need to also add these strings. Yeah, looks like so. Yep. So are we good? Can we just clear the screen now? We have fn clear, and on init we would like also to clear the screen, please. Result.clear. Moment of truth. Behold. Oh god. Almost. Try result clear. Something expected, something found. Yeah. So we should add some more errors, I think. Or file errors, yeah. This one, since we should write something on initialization, we will also have a set of these errors too. Moment of truth. Oh, very good. So now I think we should do one last thing. We should we cleared the screen, yeah, and we should do something to not put this line, because as I understand now, if we run it again, we will have this lower half of the screen filled up, and this will be just blank. Let's try it. Yeah. So what happens is that we start printing stuff when we say please print something on the screen. We do it at the cursor position. And what we want is to put the cursor position at the very beginning, at the upper left corner, and there is also an escape code for that, if I remember correctly. And we will call it something like reset cursor, I think. Or we can also do it in a sequence with clearing the screen. Right? I think we rarely should clear the screen, but save the cursor position. It would be convenient if we can clear the screen and also reset the cursor position. Yeah. Okay. We will later optimize it, but for now we will just do it in two separate calls. So let's find something to home. Yeah, and this is left bracket H, capital H. Yep, let's do that. We cleared the screen, or we can do it like that. And very good. And now one more time. Very good. So I think this is good enough. Yeah, like so. Like so. Yeah. We should also, I think, restore the screen to the last state we had. So for example, if I use my current editor, Cocoon, here I enter it. When I quit, it restores everything as it was before. So I'm not yet sure how to do that. We should somehow save what we have before, and we probably do it here. But I'm not sure if we also save all the data that was previously on the screen to restore it later. I'm kind of lost in all these flags. I do not fully understand all their meaning. Okay, but we still have some progress. So what would be the last thing we would like to do right now? Well, maybe it is all we want to do for now. Yeah? It seems like we did some progress. We can output to the screen. Yeah, we can clear it. We can output it. It's pretty fast without any flickering, because we use separate calls. Like here, we do some calls to put lines, and we do some calls. Like every line takes 2 write calls. One to write the number, another to write it here, the actual line of this file. But it's still pretty fast. Yeah, what about if we say this is going to flicker? Yeah, a little bit. I can see a bit of how to say it, when something tearing. Yeah, I think it's called tearing. Maybe you don't see it on the recording, yeah, but I can see like a bit of tearing happening on the screen. Okay, so this is our working version. Let's commit what we have. Yep. Print out the file content to the screen. Okay, this seems enough for today's session. Let's continue in the next session. So, see you. Bye.